Good day everyone, I am Edric Ato, ID 121 and I'll be teaching CALENG2 quiz number 3. The topics that will be discussed for today are solids of revolution. So let's get right to it. The problem for today is as follows. The region is bounded by the curves y squared equals 4 minus 4x and y squared equals 4 minus x and the x-axis. Find the volume of the solid thus generated about the line y equals -1 using a single integral. Set up the volume of the solid integral thus generated about the line y equals 0 using the vertical element. So first, let us graph what our problem will look like. Okay. When we're going to be graphing, this will be, let's use a blue marker. There. This is the graph of y squared equals 4 minus 4x. Minus 4x. Let's use a red marker for the other one. The drawings are not drawn to scale, so the red one is y squared equals 4 minus x. As you can see here, we have the x-intercepts 4, 0, as well as 1, 0. Let's place that in a better position. 1, 0. There you go. And we have common y-intercepts 0, 4 and 0, -4. But what we actually want to know is this area right here. If we revolve this area about a line y equals -1 for letter A. So let's draw that again, but this time just getting this is y equals -1, which is our axis of revolution. This is our y squared equals 4 minus 4x. And this is our y squared equals 4 minus x. Again, the drawings are not to scale. So our area would be like this. If we want to have a single integral, what we're actually going to be using here is we're going to be using the horizontal element. And since our horizontal element is actually parallel to our axis of revolution, we're going to be using v is equal to the integral of from a to b of 2 pi RH dr. Okay, so since our element is horizontal, so dr equals dx. Sorry, no, not dx, but we're going to be using dy. So our r should be in terms of y as well. Our r and our h should be in terms of y. Now, what would be our radius? Our radius is actually the distance of the element itself to our axis of revolution. So if our element here has a y coordinate of y, okay, it has a y coordinate of y, our position is actually going to be, our uppermost position would be equal to y, and then we want to subtract the value of our axis of revolution, which is -1. Thus, our radius would be y plus 1. The height of our cylinder is actually going to be in terms of y as well. So it's the rightmost minus the leftmost. So we're going to be getting it in terms of y. So we're going to have to convert these functions into their y, corresponding y's. Okay, so this is going to be y squared is equal to 4 minus 4x. Let's try to isolate x. So this is going to be y squared, 4 minus y squared equals 4x. So x is equal to 1/4 times 4 minus y squared. Okay? For the other function, we have y squared equals 4 minus x. Now simply, x here is equal to 4 minus y squared. So our h would be equal to the rightmost, which is 4 minus y squared, minus the leftmost, which is 1/4 times 4 minus y squared. So let's simplify this even further. This becomes 4 minus 1 minus y squared plus 1/4 y squared. This is simply equal to 3 minus, this is going to be minus 4 plus 1, so minus 3 over 4 y squared. For our a, since we're using dy, we're going to be using the lower limit. So our lower limit here is actually 0. So y equals 0. And our b is y equals 4, which is our upper limit. Oh, I apologize. It's not actually y equals 4. It's y equals 2, since it's going to be y squared. Since it's going to be y squared, it should be y equals 2 instead of y equals 4. So, let's substitute all that we know. So our volume is equal, the volume is equal to the integral from 0 to 2 of 2 pi times our r, which is y plus 1, times our h, which is 3 minus 3/4 y squared, dy. Okay, we could simply put out the 2 pi since it's a constant, and let's distribute. Let's multiply y plus 1 and 3 minus 3/4 y squared using the FOIL method. So this becomes 3y minus 3/4 y cubed plus 3 minus 3/4 y squared dy. So this would be equal to 2 pi times 3/2 y squared minus 3 over 16th y to the 4th plus 3y minus 1 over 4 y cubed, evaluated from 0 to 2. Since the lesser number is 0, we could simply just substitute 2 into this equation. So our volume would now be equal to 2 pi times 3 halves times 2 squared, which is 4, minus 3 over 16 times 2 to the 4th, which is actually equal to 16, plus 3 times 2, minus 1/4 times 2 cubed, that's equal to 8. Simplifying even further, okay, we could cancel this becomes a 2, we could cancel this, we could cancel this also becomes a 2. This becomes 2 pi times 3 times 2 minus 3 plus 3 times 2 minus 2. This becomes 2 pi times 6 minus 3 plus 6 minus 2, or simply 12 minus 5 is equal to 2 pi times 7. So our volume is actually 14 pi cubic units. Now, let's use the vertical element setup. Okay, for the vertical element, let's use a different page. For the vertical element, we are going to be forced to use dx. As you can see here, we're going to be using y equals 0 as our axis of revolution now. But as you can see here, when we're going to be using the vertical element, there will be two different areas. One area has a hole in it, or what I would like to call as the donut, and the other area is solid, or a disk. The other area is kind of like a solid or a disk. The two areas can be separated by this white line. So this would be area 1, this would be area 2. Now for area 1, this is actually going to be your ring. So its volume is equal to the integral from a to b of r outer squared minus r inner squared dh. Okay? So our lower limit, or our leftmost limit, was actually going to be equal to x equals 0. Our upper limit, or our rightmost limit, is going to be this intersection right here. This intersection is actually 1, 0. So our upper limit is equal to 1. Our outer radius would be equal to our red line, which is y squared is equal to 4 minus x. Since it's going to be y, since we need to convert y squared to y, we simply add a square root. So it's a square root of 4 minus x. Our inner radius is going to be the blue line, which is y squared is equal to 4 minus 4x. Since we need to convert y squared to y, we simply just take its square root. And finally, our dh is dx, since we are forced to use the vertical element. Substituting, this would be equal to v1. Substituting, we get v1 is equal to the integral from 0 to 1 of 4 minus x, since it's going to be square root squared, minus 4 minus 4x, once again because it's square root squared, dx. Simplifying even further, we are going to get the integral of from 0 to 1 of 4 minus x minus 4 plus 4x dx, or simply 3x dx. Taking the integral, we are actually going to get 3 over 2 x squared evaluated from 0 to 1. Since 0 is the lower limit here, we could just substitute 1 to the equation. So it becomes 3 halves cubic units. But we are not yet done there because we still have an area 2 to consider. Area 2 is what I like to call a disk, and its volume can be calculated by the integral from a to b of r squared dh. Well, I actually forgot one very important thing here for both of these. It is actually 2 multiplied by 2 pi. Or no, by pi. It's 2 multiplied by pi. So our answer for V1 should actually be 3 pi over 2. So for a disk, it's actually pi times the integral from a to b of r squared dh. Our lower limit would actually be equal to 1, and our upper limit is going to be the other intersection, the other x-intercept, which is 4, 0. So our b is equal to 4. The radius would be just the red line. So it's going to be 4 minus x, but since that was y squared, we need to convert it to y. We take the square root. And finally, dh is simply dx. Substituting, we're going to get pi times the integral from 1 to 4 of 4 minus x, since it's going to be square root squared, dx. This is simply going to be pi times 4x minus 1/2 x squared, evaluated from 1 to 4. Now here, we're actually not able to take the not able to just substitute 4 into this equation anymore, since our lower value here is actually 1. So what we're actually going to do is substitute both 4 and 1 into the equation. So that would be pi times the quantity 4 times 4 minus 1/2 times 4 squared plus minus 4 times 1 minus, if you subtract a negative number, that's simply adding it, plus 1/2 times 1 squared. We're going to be getting pi times 16 minus 1/2 times 16, so it's 8, minus 4 plus 1/2. This is equal to 16 minus 12, so that's 4 plus 1/2, that is equal to 9/2 pi cubic units. That is just volume 2. We're not yet done. The total volume is actually going to be volume 1 plus volume 2. We already calculated for both of them. Volume 1 is 3 pi over 2 cubic units. Volume 2 is 9 pi over 2 cubic units. So this would be equal to 12 pi over 2 cubic units, or 6 pi cubic units. And that would be our final answer. I hope you learned a lot during this video. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. Once again, this is Edric Ato from Syntax, paving your way to excellence.